So I'm talking about Kepler, and a lot of what I'm talking about isn't current science. It's been disproven as totally crazy. But I find Kepler really interesting because of his approach to science. So he approached science by trying to work out a system or a pattern a priori, and then look to the world and try and fit his pattern into the world. So I think that's really interesting because some of the stuff he came up with we still learn at high school today in physics, and other stuff is totally crazy. Like, I'm going to play a little, hopefully you can hear it. This is what Kepler thinks the planet Jupiter sounds like. But the idea is that he thought that the orbit of the planets resonated like the strings on a violin, and that each planet had its own harmony, and he used maths to prove the harmony of each of the planets. So I'm just going to go through and try and explain how he got to that point, and look at how he interwove his religious ideas to get to what he wanted to prove, but actually came up with such solid science that we're still teaching it 400 years later. So there is Kepler, and he does have a very lovely theory. So Kepler lived in very different times to now. There wasn't a big divide between religion and science. So he was a deeply religious man, and for him the point of science was to prove his religion. He wanted to work out the kind of grand design of the creator. And now we've kind of separated the two, but we still use what he came up with, and he was using it to show that there is a God and there is a design. Okay, so when Kepler was being an astronomer and a mathematician, generally people still thought that the Earth was the centre of the universe, and he was an astronomer, and that also meant that he worked as an astrologer. So his big break in life was to go to Prague and be an assistant to Tycho Brahe, and then when Tycho died he became the royal astrologer. So that they were the same role. He worked out all the maths and then plotted the charts and advised the king on when would be a good time to go to war, when would be a good time to start a new business deal. That was all based on the chart that he plotted out. And it was also a very sad time, and I think in terms of how strong his religious belief was, he was an astronomer during the 80-year war, where it was just constant destruction. And it's interesting that in 1611, which was the year before he came up with his most important discoveries, so much went horribly wrong. So his wife developed signs of epilepsy and then died. All of his children got smallpox, and one of them died. He lost his job. The war meant he had to leave where he was working. And all these kind of horrible circumstances actually led to his most persevering discoveries. So he's been described as the first astrophysicist and the last scientific astrologer. So he was really on the brink of the scientific method as we know it now, and also he was still into the deeply mystic astrology as well. And just as an interesting aside, one of the biggest moments in his life was defending his mother in a witchcraft trial, which went for years. And the reason why his mother was accused of being a witch was actually he wrote one of the first science fiction books ever. And in the science fiction book, he included a line that the mother of the narrator, which everyone assumed was him, spoke to a demon. And from his writing in a science fiction book, his mother was actually accused of being a witch and was tortured, and eventually Kepler was able to save his mum, but that took kind of 2 years out of his scientific career to save his mum from being killed for being a witch, basically. And so what is really interesting, as I said at the start about Kepler, is his approach to science, and that he was looking for patterns, and the great work of man was to be able to discover these patterns and understand the work of God. Oh, sorry. It's a nice quote that shows his approach to what science meant. So I'm going to go quickly through the stuff that we learned at high school. I remember I learned at high school the science that is still being passed through today. So there's 3 laws that we still learn about of planetary motion. So he was the first person to prove that the planets travel in an ellipse around the sun. And that if you look at the time, if you have equal time distances around the ellipses, and you look at the area from the sun to those different time points, that area will always be the same. And then the final law was a really useful tool to be able to, if you knew where one planet was in a solar system, if you had the coordinates of one, you could then work out where everything else in that solar system was. And this should, if I can get it to work, this should explain the second one. Okay, so this is the idea that at every same point in time, the area of the ellipse is the same. So that area is always the same. And it's amazing to think that he came up with these ideas just with very rudimentary telescopes and no computers. The data was all laboriously plotted. So that's what we learned in high school. But at the same time as what we learned in high school, he had these, it was embedded, it was kind of hidden within these broader, crazy theories about God and how God is embodied in the world. And his first big claim, which we would look at and think is pretty outlandish, is that he was looking at the structure of the solar system and trying to think of a pattern that would explain why the planets are arranged in a particular way. And he was very much based on geometry. And so he looked at I'll show you a picture. He looked at Plato's 5 platonic solids. And he, kind of like a Matryoshka doll, he kind of worked out the best geometric way to stack them in on each other. And he thought that that must explain why the planets are the lengths away from the sun they are. And he was obviously a brilliant mathematician, but it didn't quite work because it's not true, but he would always find ways to kind of fudge the experiment to make it fit this, because he believed that everything had to be in this perfect system, and this was the right system, so the figures had to fit into this. And then that wasn't kind of crazy enough. He had to build on that because that system didn't explain the elliptical orbit. So once he worked out the elliptical orbit, he needed another geometric pattern to prove that. So his next, and this was, he believed that this was his great contribution to the world, was the harmony, he looked at the harmony of the world. And he attempted to explain the elliptical orbits in terms of harmony and music. And so this is just a nice, so that's what he was always doing. He was trying to find the geometric pattern and fit it into the world. And one of the kind of more interesting analogies I thought that he made was that to him the ideal shape was a sphere. It was perfect, and he saw the sphere as a symbol for the Holy Trinity. At the center was God the Father, and then the surface was God the Son, because that's what you can see and touch. And then the equidistant lines that you can draw from the center to any point in the surface is meant to be the Spirit. So in everything that he saw in his science, he was that the only purpose of science was to explain religion and the Creator. So this is after the terrible year that I talked about before, and he got very rapturous, became very rapturous, and came up with his musical theory. Okay, so in this book, he started with what we talked about before, the Platonic solids, and stacking them on each other to work out the ratios between the planets and their orbits. And then, so they're the 5 shapes. And at the time, they only thought that there were 6 planets in the universe. So that was lucky for Kepler, because there were only 5 Platonic solids, so you could stack the 6 planets in between them. It wouldn't have been so good if they discovered another planet in his lifetime. And then, so the next step was to use musical harmonies to explain the elliptical orbits. And we've got some nice. This is what I was trying to play at the start. So this is the next picture. I think that's the original, but there's another version. So apparently this is the sound that the planets make. Approximately, yeah. And he had 2. So planets make 2 sounds. There's the individual planet sound, which is he looked at the angular velocity of the planets taken from the position of the sun, and took it at its furthest point away from the sun and then its closest point. And then if you imagine a kind of a string between the sun and the closest point and the furthest point, and you pluck that string, that would be the harmony of that planet. So these ones, that would just be 2 notes, obviously. And then these ones are when the planets, that wasn't kind of majestic enough. So he wanted the planets to be able to react with each other in their orbits and create some kind of symphony. And so he created, I don't understand, I tried to read and understand how he did this, but I really couldn't understand the calibration. So he then compared the speeds of the different planets, and then somehow condensed those different ratios into 1 octave to make the planets play on the same scale. So that's, he did it. I don't know how. I don't understand it. Yeah, this is a really nice quote of how excited he was. So for him, that when he matched the figures to match his patterns, it was such a epiphany that it was like God talking to him, saying, "Yes, you've kind of seen the truth, you've seen the light." And I just love this quote that you can feel his joy, that very agreeable feeling of bliss afforded him by this musical imitation of God. Very, very poetic. And underneath all this kind of, it seems very emotional and very spiritual. In trying to find the music of the planets, he actually did come up with this. We still learn, like, this is still true, and this is his 3rd law, which shows the proportion of the time of the elliptical orbit and the radius from the sun. And this same formula applies to any body within the solar system. So, as I said earlier, you can use coordinates of one planet, and then if you have some of the other, you can use it as a very accurate plotting tool. And for someone without computers or any devices, to be able to use this instead of, he would have had probably, a whole parcel of handwritten notes of where things should be and what to look for, to be able to predict the future, to be able to tell the king when to go to war or not. And this made it a lot easier, because as soon as he had the current, any of the kind of, as soon as he had the time and the radius, he could work out where that planet was going to be in the system. And as a kind of a sadder last note, this is just a quote that he made about the sound that Earth makes, and it's very sad, but I think that was influenced by all the smallpox and war he lived through. And then, I don't think we can go to this, but he has continued to influence not just science but the arts, and this is a symphony that is called The Harmony of the World, based on Kepler's book. And it's a shame we can't play it, but it's the most dissonant piece of music. You listen to it for 20 minutes and you feel very agitated. Yeah, that's all come from his idea of trying to see God and patterns in everything.